Okay, now we're talking about linear rate. When we talk about linear rate, there's really three things we're going to talk about in the mechanical world. First of all, we're going to talk about, linear versus rotational is kind of important. I'll mention it later also in the rotational. Linear, straight line. Anything that's moving in a straight line is going to be a linear rate. Anything that's rotating is going to be a rotational rate. Now, there's a couple things. First of all, speed or velocity. The only difference really between speed and velocity is speed is a scalar quantity, velocity is a vector quantity, so therefore it has to have direction. Now, the formula for velocity or speed, v is equal to length divided by time. Now, in a physics class, we will say distance or displacement versus time. They're going to use L over T. Be careful, because when it's written on a computer, it's going to look like 1 over T. In reality, that's a lowercase l for length. Now, in the metric system, we have meters per second, or you could also have kilometers per hour as a common one they use for automobiles, but meters per second is what we'll probably use more in the lab. In the English system, you would have something like feet per second, or of course miles per hour, which is one you already know. Now, there's another thing that is rate dependent, and that's acceleration. Now, acceleration means you're changing speed and or direction. Now, we're not going to necessarily play as much in this course about changing the direction being a form of acceleration, but it is. It's kind of important that we're aware of that. Now, A is equal to delta V over T. In other words, it's the change in speed or velocity divided by time. Now, that brings in some interesting units. And first of all, let's do the SI units, the metric units. Well, it's going to be a velocity, which is meters per second, divided by seconds. And I actually prefer to keep it that way, at least initially. The speed is changing so many meters per second each second. Now, if you remember back to your fraction days, to divide by a fraction, you multiply by the reciprocal. It reduces down to meters per second squared. In the English system, it's going to be feet per second squared. And the key thing is that. Now, there's two cases in the real world that we see all the time. Number one, rest or constant speed. Well, let's say constant velocity. If that happens, cases I can have, well, you know what rest is. Constant velocity I could have with cruise control. Or if you're pedaling your bike at a constant speed or driving a car at a constant speed, even without cruise control, you can still have constant velocity. In that case, A is equal to 0. And the key thing to realize then is the object is in equilibrium, which is a fancy word for saying the forces are equal. So remember, everything ties together. So for equilibrium, it's the forces that are equal. There is no unbalanced force. So therefore, the object's going to keep moving at a constant velocity. Another word for this would also be called a uniform speed instead of constant speed. Uniform simply means the same. So a uniform speed would be the same speed. So that's case number one, in which you're at equilibrium. There's no acceleration. You can be moving, but you have to be moving at a constant speed in a straight line. The second case that we can see is when we have a constant acceleration. A constant acceleration means we are changing speeds, but we're always changing by the same amount. The reason that becomes important in this course, gravity. Gravity is a constant acceleration for all the things we deal with on the Earth, and it's one of the few numbers you need to know for this course. It's called lowercase g, 9.8 meters per second squared. So what that means is the speed of a falling object is changing 9.8 meters per second each second. So if it's approximately 10 meters per second squared, and that's close enough to give us ballpark answers. So if I have a rock falling, initially the speed is equal to 0. 1 second later, this is 0 seconds. 1 second later, the speed is now 10 meters per second. 2 seconds later, the speed is now 20 meters per second. 3 seconds later, the speed is now 30 meters per second. That's where the fact that the speed is changing 10 meters per second each second. That's what that number tells you. It tells you the speed is changing 9.8 meters per second each second. We just simply write it as meters per second squared. In the English system, you don't have to know this number, but you'll see it. It's 32.2 feet per second squared. 32.2 feet is the same as 9.8 meters. It doesn't change just because you change the units. It's like comparing Canadian dollars and American dollars. They're still worth the same thing. It's just it takes more Canadian dollars to be equal to the same thing. Okay, the last thing under rate that you'll see is a production rate. A production rate is how many things are produced per time unit. Items per minute, items per second, items per hour, something like that. For example, you could do that with, I don't know, English essays. And you produce 1 essay a week. That would be your production rate. So you can apply that to a variety of things. Hope this helped.